So the focus for today is on solving for x in simple quadratic inequalities. So before we begin, what is the difference between an equation and an inequality? You must know that an equation has a specific solution. X equals 2, for instance, or x equals 10. But an inequality, it has a set of solutions. All the values from 2 up until 10, for instance. So anything that is in between. So let's consider this question. It says x squared minus x minus 6 is less than 0. In other words, we are looking for the values of x for which this function is less than 0. So where the function is less than 0, it's where it is below the x-axis. In other words, where the y values of the function are negative. So the first thing we see here, the function is already written in standard form, so we can go on and factorize it. Factors of x squared, it's x and x. And then we say factors of 6 that add up to 1. It's going to be 3 and 2. The bigger number takes the sign of the middle term, and the 2 must be positive. After factorizing, we have to write down the critical values, which are just the x-intercepts of this function. So these are they. After doing this, we have to represent our function graphically. So this is how it will look like. So here we know that the value of a, which is the coefficient of x squared, is positive. So it means the function is facing up like that. Right. And then here you'll say, well, this is -2 and this is +3. This is the x-axis, of course. So we can see that the function is below the x-axis between -2 and 3. So how do you say between in mathematics? You say any value of x that is less than 3, but greater than -2. Well, of course, I know some of you don't appreciate the inequality sign. So in that case, you can say it's any value of x from -2 all the way to 3 in interval notation. And then you should be fine and happy with this one. So let's try another example to make sure you grasp this. So this one says you have x squared minus 2x minus 8, which is less than 0. So once again, it is still written in standard form, so we can go on and factorize this. Factors of x squared, it's x and x. Factors of 8 that add up to 2, it can only be 4 and 2. The bigger number takes the sign of the middle term, and this one has to be positive, the 2. Then from this point, we write down the critical values. So you say x equals -2 or x equals +4. After writing down the critical values, we have to represent this function graphically. So this is how it will look like. And once again, the value of a is positive, so the function is facing up. This is how your nice function looks like. Then you say this is -2 and this is 4. So where is this function less than 0? In other words, where is it below the x-axis? Then we can see it's below the x-axis between -2 and 4. So you'll say x is less than 4, but greater than -2. Alternatively, you can say it's any value of x from -2 up until 4. And once again, you are happy. Yeah, I see you're smiling. It's nice. Now let's try the last one of this kind. So this one says you have x squared plus 5x, and this is less or equal to -4. So the first thing we must do in this case is to write this function in standard form. So meaning we take -4 to the left. So then we'll have x squared plus 5x plus 4, and this is less or equal to 0. Then from this point, we factorize our equation. So we say factors of x squared is x and x. And then we say factors of 4 that add up to 5. It has to be 4 and 1. We can't use 2 and 2. Imagine. Now, because the last term is positive, and we know that the bigger number takes the sign of the middle term, this one has to be positive as well. Then what are your critical values? Well, x equals -4 or x equals -1. Then from this point, we represent our function graphically so that it's easier to read the solution. Then once again, the coefficient of x squared is positive. So it means the function is facing up like that. So you'll have -4 here, and then you'll have -1. Remember that -4 is less than -1 on a timeline. Sorry, a number line. Right. So where is this function less than 0 once again? Between -4 and -1. But I want you to see, this one says it's less or equal to 0, meaning we have to include where it is equal to 0, where the y values are 0, which is at the x-intercept. Right. So for this one, we'll simply say it's any value of x that is less or equal to -1, but greater or equal to -4. Alternatively, you can say x is an element of all the values from -4 to -1. And then you should be happy and smiling with this one as well. Right. So we are done with these ones. Then we have to move to different ones. So we are doing as many examples as we can so that we understand the concept. That's the whole point anyway. So let's consider this one. This one says you have x squared plus 8x plus 15, and this is greater than 0. The first thing we do, because it's already written in standard form, is to factorize it. What are factors of 15 that add up to 8? So we have to come up with the combinations, but 5 and 3 are the perfect combination of factors. And they're the only combination, by the way. Now you say the bigger number takes the sign of the middle term. And because the last term is positive, this one is bound to be positive as well. Then you say your critical values here will just be -5 and -3. Right. And then from this point, we have to represent our function graphically. So this is what we say. So the value of a is still positive. The function is facing up. Then you have -5, and then you have -3 there. So what is this one saying? It says we are looking for the values of x for which this function is greater than 0. In other words, where the y values of this function are positive. In other words, where the function is above the x-axis. Do you see that? So we can see that the function is above the x-axis in these two intervals, from -infinity up until -5, as well as from -3 all the way to +infinity. So you have two ways of saying this. You can say the y values are positive, or rather the function is greater than 0 for any value of x that is less than -5, or for any value of x that is greater than -3. But if you hate this, you can simply say it's any value of x from -infinity to -5, or, so your or will be a union. You say or any value from -3 all the way to infinity. Do you see that? Yes. Let's do it again so you can see it clearly. You have to see it. There's no other way. So let's see this one. Well, in this case, you have x minus 1 into x plus 4. This is greater or equal to 6. So the first thing we see here, this function is not written in standard form. So we have to write it in standard form first. So the first thing we do is to expand these two brackets by FOIL method, of course. Why do we expand the two brackets when we can simply write down the critical values? It's because we have a 6 there. If it was 0, then we jump straight to the critical values. Are you fine? So every time you have a non-zero number here, it means you have to expand your two brackets. Awesome. So x by x, you get x squared. X by 4, you get 4x. -1 by x, you get -x. -1 by 4, you get -4. You take the 6 to the left, it becomes negative. Do you see that? Then from this point, we collect the like terms. 4x minus x, it's 3x. And then you say -4 minus 6, it's -10. Everything is greater or equal to 0. Then from this point, we have to factorize. Factors of x squared, it's x and x. Now, factors of 10 that add up to 3 can only be 5 and 2. The bigger number takes the sign of the middle term, and this one has to be negative. 5 minus 2, it's positive 3. And 5 times negative 2, it's negative 10. Awesome. Then from this point, you write down the critical values. So you say x equals negative 5 or x equals positive 2. After saying this, you represent your function graphically. So this is what you say now. Much better. Right. Once again, the value of a is positive. The function is facing up. Then you have negative 5 here. You have positive 2 there. Awesome. Then from this point, what are you saying? Then we come to this point. So here we are looking for the values of x such that this function will be greater or equal to 0. So here we can see that the function is above the x-axis in these two intervals. Do you see that? So from negative infinity to negative 5, as well as from 2 to positive infinity. But we have to include negative 5 and 2. So in the best notation, we can say any value of x that is less or equal to negative 5, or any value of x that is greater or equal to 2. Alternatively, you can say, well, it's any value of x from negative infinity to negative 5, but you have to include negative 5. And then you say, or it's any value of x. Yes, it's any value of x from 2 all the way to infinity. I think I made a mistake with another question. I think there is a place where I was supposed to use a square bracket in one of the inequalities. I think the last one of the first 3 that we did. I'm not sure. Yeah, I think so. The one that had an equal sign as well. I think I made a mistake there. I'm not sure, but if you find that mistake, you can let me know in the comment section. But I trust you by now, you are fit enough to fix the mistake by yourself. Yes, yeah, I trust you. Yes, so these are your 2 solutions for this inequality. Well, I'm not sure if there's a mistake, but I think there is. I think I used a round bracket instead of a square bracket. Yes, please forgive me on that one. Yes, otherwise you should be happy with this inequality as well. So this is the end of this video. Thank you so much for watching. I really hope it helps a lot.